for about 45 minutes, where we'll sort of break into data facilities that are more specific in their data, and then maybe ones that are more general, have a discussion about the biggest problems and topics, or anything that's been sort of brought up by these talks. And then we'll have somebody from each group report back for the last 5 minutes. And then we can sort of decide if we want to do an unconference, if there's any big issues we think we want to deal with. All right. So here is a QR code for the shared notes and a URL if you want to go and sign in there and put your name and affiliations and so on, like the other sessions that we have here. And you can put some notes or ideas also in that area. So here's sort of the general outline for our session. So I'm going to start with Matt Jones is going to give a talk for 5 minutes here.
Okay, thank you for inviting me to speak. I'm looking forward to talking today about the ways in which we quantify data quality at the Arctic Data Center and trying to sort of stimulate conversation later during the breakouts. At the Arctic Data Center, we have probably what is typical of many of the repositories in our ESIP ecosystem. We have a process where researchers from our supported community submit data packages. We run an automated system for scoring the submissions based on an automated scale of the DataOne FAIR suite. We then pass those results in the data set to our data curation team, who iteratively work with the PIs to work on the quality of the data set. And then after multiple rounds of revision, we end up publishing a data set with a DOI. So this metadata assessment tool that we developed as part of a project with Ted Haberman at the Metadig project, it's been really valuable to us. It supports diverse metadata standards and dialects, including EML and ISO, and it allows us to quantify the ways in which individual metadata records that can be quite detailed conform or don't conform to various recommendations that we want to enforce. And so we generate a score and we can use this for guidance. And researchers submitting data can also use it for guidance. They get a report that looks like this, that has a bunch of specific feedback about the individual fields that they may or may not have been able to improve upon. And then ultimately, we take it into a human curation step where we have people evaluating that. So if you look at the overall sort of way in which our curation system works, these dots for each of these findable, accessible, interoperable, and reusable categories, there's a left-hand bullet which represents the initial score at submission, and a right-hand one that represents the score after we've done the curation process. You can see across the categories in general, we're having a pretty significant impact on the quality of the incoming metadata records. And if you look at that over time, you can see for each of these 4 categories, we've had a general increase in the metadata quality of our corpus. This is a running average of quality across time. But what's really interesting is you can divide that impact that we've had into 2 different groups. So this rise that represents this first bump, the difference between the dotted line and the solid line, is the effects of our curators on what happened after the submission. But if you look at this line, our historical growth to here, this really represents the improvements in our tooling and our system and our metadata documentation and support that helps the initial submission that came into the repository be improved over time. And we're trying to increase both of those throughout all of our systems. So our next steps are basically to be working on to move beyond metadata assessment and start focusing on data quality assessment. So data quality, unlike metadata quality, requires significantly more computation in order to open and look at all of the different data sets. For the Arctic Data Center, we're a generalist data repository. We support lots of disciplines from atmospheric science and oceanography to biodiversity to social science, economics, every discipline that might be working in the Arctic. And as a result, it's very hard to develop just a universal set of quality checks that works across all the different types of data that we get in. So our concept that we're working towards is to develop a set of generic quality checks that apply to any data set, regardless of discipline, and then a set of project and domain quality checks that represent checks that come from the communities of practice that are working in a particular area. So that might be project level stuff that comes from particular labs and PIs, but it might be like disciplinary stuff, like checks that are specific to soil science data. And then we want to be able to produce those reports for both data sets and for projects. So this is these two columns represent some examples of the types of things we'll do on both the generic side and the domain and disciplinary checks. So things like data type conformance, data model normalization, malware scans and checksums matching the actual uploads. Those are all important parts of things. But then domain specific checks like taxonomy for biology and unit and measurement semantics for particular fields. And so we're working towards developing out this framework that allows us to scale that metadata checking system to the many hundreds of terabytes of data we get on the data side. And that requires us to build out a more scalable system that we'd love to have collaboration on in building out a system that interoperates across different repositories. So in 2019, Ted Haberman and I put together a couple of workshops that involved a bunch of individuals from the people and the logos on the right side of this, where we took a deep dive into what set of common metadata metrics, quality checks would be really important for a community. And we came up with sort of this DataOne FAIR suite that we've been using for the metadata checks. And I think that we really need something similar, a community process for data quality checks, where we could agree upon for both generic checks and for domain specific checks, what are a really valuable set of quality checks that we could share and represent across different repositories. So with that, thank you. And thanks to all my collaborators on these various projects.
Thanks, Matt. Next we have Corina Grease from the slide here. There we go. And this doesn't, you have to click on this. So this should be good. Okay. She's from the Environmental Data Initiative.
Well, thank you for inviting me here. And I'm just going to go through our workflow on how we ingest data and at which points we try to improve metadata and data quality as the data come in. So we do have a little different process here probably than the Arctic Data Center, because we do work with a lot of professional data managers that are working at sites and are responsible for their data management. So that is that upper right block there left for you, the various local metadata systems, which have evolved over many, many years. And they have evolved in a setting of a community of practice where the data manager regularly get together and regularly exchange ideas and exchange methods and best practices and best approaches. So we do also have for single investigators the way into the repository, which is our EasyEML online metadata editor, which is there on the bottom. And in that process, the EDI information managers are involved for reviewing process. The local systems, we in EDI support through various tools that are out there and that everybody can use. So there is an R package to generate the ecological metadata language. There's an ecological metadata language parser and validator, which is independent from the repository and can be used, and some other tools that can help with the data. On the right side here, the EDI repository provides several quality checks during the submission process. And we do provide a staging environment where people can first sort of show the data, how they look like, and the data providers can look at them and see what the quality is. And they can use what we call the Data Explorer. So I'm going to go through all the steps quickly. The local metadata systems, I have to admit, I don't really know a whole lot about them. They usually manage long-term data that are repeatedly updated in EDI. So there are every year or every month or every week, there are new data coming in that are updated. And then of course the one-time short-term projects that are associated with papers or theses or you name it. The data submission workflow usually works with a data manager who collects the metadata from researchers and technicians. Usually some metadata forms have been developed, they go into databases or not. And then there's frequently some code involved that will generate the ecological metadata language XML file. And then the local data manager submits to EDI. For everyone else who doesn't have their personal data manager at the site, they can submit through our online form-based metadata editor we call EasyEML. And in this metadata editor, there are a lot of checks built in. You see here what happens when somebody clicks check metadata, and there are a lot of suggestions that will help improve the metadata. Then the same as with the Arctic Data Center, there will be a cycle of back and forth with the EDI data manager that will make further suggestion, and then the EDI data manager eventually submits, and when everybody is happy, it submits to production and assigns a DOI. During the submission process, there are more quality checks and a very detailed report that comes back for everybody to see what might be wrong or what might be improved. And I mentioned already the different systems where the data provider then can actually see the metadata and review them. The Data Explorer will run through the actual data files and will give a basic profile for every attribute within a data file. So on the middle bigger screen, you can see what that will look like. So there's basically a summary statistics for every column within a data file, and it allows for pretty quick and simple plots that usually bring up data problems within the data file. And that is a process that we usually ask the data provider to do in the staging environment already before it goes into production, and a lot of people find some problems if they haven't been discovered already before in the metadata editor. And all of that then is leading to this fair evaluation that we recently did for all data in the Environmental Data Initiative and published in that paper. And these are the exact same quality checks that Matt just introduced, and what you can see is that if you could see it, if you could read it, is that the ones that we're not doing very well are mostly about IDs, and IDs have only recently become available. I mean, the RR IDs for institutions, the ORCID IDs are not all that widespread, and we now have to get them in to data sets that have been published many years ago. So there is a bit of an updating problem involved here, but everything else is okay and acceptable in the terms of quality. Thank you, everyone.
Next we have Bob Downs from CDAC.
So I'm going to talk about our workflow at the CDAC. And as you see, there are 4 steps here: submission, review, curation, and publication. And then we kind of present this in a simplified way, but I'm going to get into a lot of the details now. So for CDAC data submission, we try to make it completely transparent and have a submission webpage so people can go out there and read about it. And basically it's a 2-step procedure where they can first fill out our form, and we're going to have our science team review that, and they're going to decide whether it's a potential candidate or not, and if it's not, it's going to be declined. Otherwise, then they're going to invite the data producer to give us their submission. And then at that point, the science team assesses the value of the data for the user community, and they create a data dissemination plan to present to the CDAC user working group in NASA. And then they're going to review that and look at the data and the data dissemination plan. And if they decide to go forward, then we're going to notify the data producer that the data curation will begin. Otherwise, it's going to be recommended for an alternative route. Once we are moving with the data dissemination plan, we get into data curation, where we create the landing page, any services associated with it. We ask the data producers to contribute to the metadata and the documentation. The data are curated and described in the metadata and the documentation, and then dissemination information packages prepared and verified. And we have a review from our internal alpha system that's conducted by the Configuration Management Board and by the production team. And then an external beta review is conducted by the peer reviewers in the Configuration Management Board. Once the Configuration Management Board is satisfied that everything has been addressed, then we can go on to publication. An archival information package is then created and ingested and distributed to various locations. The data are published. A list of frequently asked questions, or a FAQ, is created and published out there. And then we inspect all the artifacts that are out there and make sure that they're all working. The user services people then answer any questions associated with the data, and to make sure we're not getting redundant questions, they put those questions add them to the FAQ, and we engage in continuous quality improvement based on any comments or questions that we're getting from users at that point. Thanks.
Next, we have Chris Jenkins from InStar. Yeah, I think so.
Okay, thanks. So I'm Chris Crosby. I work at the EarthScope Consortium, but for this purpose, I'm talking about Open Topography, which is a relatively small National Science Foundation funded data facility that's been around since 2009. It's a collaboration between the San Diego Supercomputer Center, EarthScope, where I work, and Arizona State University. We're a very specifically focused repository. We're really interested in topographic data in the most specific sense. So this is everything from data collected from spaceborne platforms like laser altimeters, things like shuttle radar topography mission, all the way down to data collected by laser scanners on tripods or photogrammetry from drones. So we have some advantages in that the data tend to be pretty consistent in their sort of formats and things like that. So primarily we're dealing with data sets like point clouds in the upper right. This is the Indianapolis Motor Speedway. And then raster derivatives of those data sets, so topographic models and their sort of derivatives. We're really interested in both data archive and data distribution, but also data reuse, enabling ease of use. So we put a lot of visualization and processing tools next to these data sets. We get a lot of data from a lot of different sources, much like some of the previous presentations. We have the ability for users to upload relatively small data sets. We built this for sort of the explosion of people with drones out flying around their field sites, producing topographic data sets that want to publish those with a DOI. We still get a lot of data via like the SneakerNet hard drive shipped to us because these are relatively large data sets. They're typically thousands of files. And so a lot of the magic happens in this validation and curation step where we do a lot of programmatic data evaluation. So these files are too large, there's too many points, the data sets are too large for a human to walk through them. And so we're looking at things like consistency of coordinate systems in the headers of files and appropriate bounding boxes and lots of things like that. And then we also provide the user or the data contributor the ability to provide us with a descriptive metadata, things like funders and other sorts of elements that travel along with them. That data gets published with a DOI after it's been approved through our curation process, and it appears for users to access via our GUI, our APIs, and our bulk download pathways. The other thing that we do that's maybe a little bit different than people here is we're trying to build a centralized repository, sort of a one-stop shop for these data sets. And so some of them were not the authoritative archive. So we are doing things like federating data out of things like Amazon Web Services public data sets. And so that's a sort of, I won't talk much about that here, but that's an interesting additional sort of complexity in that we're sort of not the authoritative archive for these data sets. So we're trying to validate data that we don't actually hold. And that creates some additional complexity as well. Metadata space, each of these data sets typically is collected by some larger organization, oftentimes commercial. A lot of the really stuff you care about from a data quality perspective is not machine readable metadata. It's sitting in like some PDF report that comes along with the data set. And that creates a whole bunch of problems. We publish these PDFs, but they're not easy to scrape and sort of put into databases. Everything that we can sort of programmatically extract, we put into ISO 19115 and publish via OGC standards like catalog services for the web. As I said, though, we do have the advantage that the way these data sets are handled in terms of file formats and kind of quality are relatively consistent because this is a big industry. There's a lot of money being spent on this. So there's file level standards like the ASPRS has a specification for point cloud files and what should be in those files. So that makes it easy for us to programmatically extract metadata. And then a lot of the big players that we're working with are groups like the US Geological Survey or Land Information New Zealand that have these national mapping efforts. And so they have very specific standards to decide if the data if they're going to pay the vendor before they take delivery of the data set, basically. And so a lot of the data quality evaluation is happening upstream of us in some cases. Some other group is sort of doing this initial review of the data sets. But there are a lot of challenges with these data sets that I think are maybe a little bit interesting to think about in the sense that file level validation is really easy, like programmatically walking through files and reading and looking for consistency, that's not hard. There are 63 trillion individual laser bounces, measurements of the Earth's surface in open topography, and no single human can go through and look at that data and evaluate if it's good. These data sets are also really spatially variable. So in one spot, they may be really good, and you go tens of meters away and the data is really bad. And that's a function of how these data sets are collected, and that's a tricky problem as well. And so we're not doing this. And so we've talked about things like crowdsourcing this, providing a layer where users can sort of spatially mark up data sets as they're interacting with them to provide additional data quality control. Also, maybe potentially just processing new derivatives as the data come through our ingestion pipelines to produce layers that show sort of spatial variability of quality, things like vertical accuracies. And then at the other end of the spectrum are these small data sets that are produced by the community of PIs and graduate students. And those are tricky because there's no standards right now in the community about how people report their survey processes and their accuracies and their processing workflows. And so ESIP actually, I think, still has a drone cluster that's talking about some of these topics because this is very relevant there. And I already mentioned sort of machine readable sort of issues about these. A lot of the information about these data sets end up in these big files. So that's it. Thank you.
Thanks, Chris. So last we have a ENP page.
Yeah, let me get that one user. Sorry.
Thanks. Thanks. Great. Thanks so much for the opportunity to talk. I'm going to talk about BICODEMO, the Biological and Chemical Oceanography Data Management Office, and a couple of the practices that we engage in that allow us to dig in as a domain repository into more of the quality of the content versus the presence and absence of metadata and data quality. So looking at that I and R. And I'll start like everybody else with our workflow. It's pretty similar to Arctic Data Center, maybe not so much to EDI. But there's a collaborative process with the data submitter that happens at submission time. We have domain-trained data curators at BICODEMO who look at the content of the metadata and the data files. This appraisal happens back and forth iteratively until it's accepted. Goes through a data processing queue, talk a little bit more about the tools that we use there. Data set, landing page, metadata, and data files are connected together. We allow the submitter to review this, put eyes on this, similar to EDI. We publish this out and then archive at NCEI. And so the red stars here are just areas that I want to dig into a little bit. At submission time, we've developed a web-based interface that allows the submitter to come to BICODEMO and authenticate with their ORCID and begin to fill out standardized metadata fields. These are all checked for quality of content by our data curators. As I said, this is an iterative process. I'm not going to read through all the bulleted features on the side, but we also use this tool as a sort of workflow management by our data managers to craft and sort of aggregate metadata and connect those data files together. A lot of quality checks are built in here for missing information as they're building that package. And then, of course, they can dig into any of the files to read, to actually look at the file quality themselves. When it comes to data processing, we've developed a tool in collaboration with the Open Knowledge Foundation on leveraging frictionless data package pipeline tools. And we've developed this tool called Laminar. And this is used by all of our data managers, and it employs the philosophy of declarative workflows. So one of the challenges that we were trying to overcome with domain curation is that we have knowledgeable domain data managers with varying levels of code savviness. And declarative workflows sort of abstracts the idea of writing code snippets to do common file processing activities into this buildable abstracted pipeline that the data managers can run. And so they're actually creating their own code in an abstracted way. So a couple of things that does is to reduce human error. It increases their efficiency. It promotes the idea of standard operating procedures across all of our data managers. It tracks provenance. So we get a provenance record of everything that's happened to that file. And as you can see, there are several error messaging that the data manager can resolve data issues. This is for tabular data, which makes up probably better than 70% of our data holdings as they come in. So everybody uses Laminar in-house, and it really has streamlined a lot of the data quality. So they can track errors inside the files as they're massaging and sort of wrangling data, and then it will do sort of validation checks against open formats like CSV. So when the data files are processed and the metadata is aggregated, we create, again, in this leveraging our submission tool, we create a draft data page that we then push to the submitter and the data authors again to review, similar to EDI. It's an iterative process, again, catching any final challenges or errors that are found in metadata and data. This is also the final step before it's pushed to publication. When it does get to publication, again, we have another series of automated tools that we use for data manager interaction with the DOI to build the package. There's congruency checks again on metadata, ISO compliance. Here again, you can see, if you could see, I don't know if you can see that, but there are little yellow flags that come up if you're missing something here for the DOI package. Then our data managers go in and actually open up the files to make sure they're valid and adhere to the standards and the formats. And then the DOI package is deposited in the archive. So I think we were asked to maybe talk about any remaining challenges, and I know Matt mentioned a couple, and I agree on so as domain curation, BeacoDemo does dig into the observations. We open up the file, but currently we are able to quality control some of the observational metadata. So oceanographic data, typically cruise-based, we can dig into position, date, time, those types of really common across the board observation types. What we're not good at, even though we do have that domain expertise in our data managers, is the huge breadth of heterogeneity in the research data types. So to solve some of that, to get at a base or core of hydrographic data, we're investigating the use of a NOAA framework called the Quality Assurance of Real-Time Oceanographic Data, or QURTOD, that provides us framework that would allow us to leverage sort of flagging system for hydrographic data in temperature, salinity, oxygen, very common across a base suite of hydrographic cruise data. And then, of course, communicating meta and data quality to end users, looking toward that information quality cluster that exists here in ESIP and maybe digging into that. So that's where we're headed. And I think that's it. Yeah.
So maybe we could have time for one or two questions. If there was something pressing you wanted to ask one of the presenters, we could do that before we go on to the breakout. Do we have a microphone?
Yeah, thanks, Nick. Ted Haberman. This really interesting presentations, and I think Corinna brought up something that I think is really important, and it's something that I think a few of you hinted at, Chris too. But a lot of these, everybody had their workflow diagrams, as I think it was Danny that said, "Here's my workflow diagram," and they all look like sort of one-way streets. And there's an iteration prior to submission. But I think one of the things that we need to think about, and this is what Corinna mentioned on her last slide about identifiers in particular, but other things as well, that there's a process of curation that goes on after the data set gets into the archive. And I sort of made up a word for this called recuration, because it sounds like recreation and we all like that. So and spell checkers have problems with that. But anyway, the process of coming back and the sort of the ongoing process of curating data sets through time, either because potentially users find problems with those data sets, or they do some reprocessing that introduces or identifies some problems, or new identifiers, as Karina mentioned, are adopted and used in the in the communities, or new elements of metadata standards might come out. Metadata standards evolve through time. So we have a session tomorrow. We're going to be talking about this in 3 or 4 different repositories. But I think it's really something that's important. The earlier session in this room on, or it wasn't this room, but sustainability and service models for repositories. This process of recurating is maybe even a more important thing for, or equally important, at least to the initial process of curation that you provide as a service for your users, right? They submit you something, you help them improve the metadata or improve the data, and then you put it into the archive. But you can also provide an ongoing service of recuration and introduction of and augmentation of existing metadata. So that's an idea that I think would be interesting to follow up on either tomorrow or in the future in ESIP. Thanks. Yeah, Danny.
Are you talking about versioning, or are you talking about annotating things as tech comes along, like annotating
I'm not talking about versions of data sets. I'm talking about metadata that gets annotated and, yeah, versioning, augmentation of metadata, I would say.
But there are two things, right? Maintaining metadata changes over time, but then annotating as new technologies like PIDs come online, right? So the content may change. We didn't get an author or the abstract, there was something wrong with the abstract or whatever that is, curating over that time to the content versus like annotating as a new technology comes along. Like now we can add these PIDs to, or ORC IDs or something like that. You're going to say something? Yeah.
Yeah, I think the recurating metadata is one thing, and we feel pretty comfortable doing that and basically adding value through annotation or corrections. But we also have a category of errors reported by data users that come back and find fundamental flaws with a data set for which the PI that might have contributed it, like we have a lot of data that was contributed 15 plus years ago. And so those data, we're not as comfortable with making those fundamental changes because of basically a lack of domain knowledge and a lack of accessibility of the people that really knew those data sets well. And when users come back to us with frustration from finding historical data sets that weren't that great, I'm still at a little bit of a loss about what to do.
Yeah, I would like to add to that. So even adding something to metadata is a question of whether we should just do this, or does it have to go back to the originator, the data provider? There are a lot of questions that are coming up with this re-curating or continuously curating, especially with data providers who are not around anymore. Yeah. Well, we guarantee immutability, so are we going to change something?
I mean, our idea was to have a breakout, but if we want to just have a large discussion, that's, yeah. We were just going to break out into sort of different groups that have similar type data repositories and discussing their issues, but maybe we can just, I mean, I don't know. We could continue on this discussion. It seems pretty fruitful. Anyway, let's see here. So what we were thinking when we were proposing this session is that, I mean, who here like manages or runs or staff at a data repository? So about 50% or more. So what we were thinking was that, you know, there are some data repositories that are very specific, and then there's others that are are more generic. Basically, it's like, how much metadata do you have? Do you have a data model, that sort of thing? Maybe the data repositories that are more similar would want to have a breakout group together. We have about 50 people here. Usually, I don't know, a group of 12 or 10 or 8 or something is good. So how about we have 6 groups, and sort of more general ones in the back and more specific ones in the front. So let's stand up and try to do that. Oh yeah, and people online, if you guys want to have your own discussion, and then everybody should try to get a group reporter, and we'll report back for like a minute. All right, we're coming to the end here. We wanted to do a quick report back. So I'll just move this around, and whoever's going to give a quick few-minute summary of what they think was a good highlight for their group. Anyone in? All right. All right.
All right. I'm gonna do this and, you know, throw stuff at me if I get it wrong. And you know, take the mic if I don't. So I would say if there was a central theme maybe to what we talked about as the middle, sort of the more general group, is just the need for flexibility, that there are not a lot of absolutes that you know, we could share necessarily across the board. Half of our group are IMs, right? Or LTRIMs, and so which I see some head shakes. Should we explain IM? Okay, go ahead. Information managers. At the long-term research sites. Did you guys? Okay, and so they there was obviously a lot of things that they did share, but also unique experiences that were particular to the data generators that they work with. We also spoke about, oh boy, now I'm losing it. I lost the train.
I think where you were going was that since we're the middle group, you know, we're like not super specific, but also not ultra general. And so we have to walk this line between developing tools that are relevant for the specific people, but also, you know, we can't develop 1,000 tools, you know, for every single little data set that we get, because we get a lot of different types. And so we talked a little bit about just the difficulty around that and strategies for trying to ensure data quality, trying to, as a repository manager, trying to help researchers submit high quality data and metadata while sort of walking that line and, you know, acknowledging that we have limited resources for developing tooling.
That was great. Thank you. Wait, one more. Chris, would you mind making that last point that you made about, you know, flexibility for, just because I thought it was a really good one that other people were finding out.
Okay, so this kind of comes to like what Ted was talking about, or recurating data collections. And so my training is as a librarian, and in a library, we're pretty free to modify our catalog records to improve discoverability, and I think that in the science world, we need to figure out a way to separate the fixity of our data from the fixity of our metadata in a way that lets us improve metadata. Otherwise, most of the assets we have now in 10, 15 years, there'll be no one attached to that who can improve it. And as like fair data becomes more actionable, we're gonna not be able to make most of our data fair. So we need to kind of find a way around the hand-wringing about the fixity of metadata and figure out something we can do about that.
Thank you, guys. Let's see. Margaret, a report from this group.
Okay, so we are the, oh, no, no, I'll hold it. Okay, so we are called ourselves the middle left. We're like domain repositories, but somewhat general. And we talked, let's see, we tried to answer the question, what are the commonalities that could be harmonized? And just in looking at the presentations at the beginning of the session, we noticed that not everyone talked about including fair assessment in a submission workflow. So the community should determine if this is a goal and then identify the common tools and reuse them. We talked about recurate, I still can't say it, recuration. So recuration of either data or metadata should be documented as part of the metadata. How that looks might depend on several things, because you have to recognize that there is a spectrum in what kind of fixing happens, like from a typo to a completely reworking of a data table, and the different solutions will apply across that spectrum. And then finally, about the contributors themselves, the contributors need to be aware of the implications of the license that they agree to when they submit data, and that many licenses mean that their data can be reworked without their permission. Anything else? What I miss?
Thank you. Do we have a speaker here? Stace, I guess.
Hi, we're the front left, the highly specific. And I chose this group because I work at an institution with earth and life scientists, and I like to help them choose a repository to submit their data to. So I asked a provocative question as we learned these. I said, how do you get someone to choose you over Zenodo, right, when you need a DOI the next day? But we learned about the value added from each of these specific repositories represented. And then we also learned from each other how different groups assign a DOI at different times in the workflow and how that works with their scientist contributors when they're publishing their papers.
All right, well, thank you everybody for coming to the session. And yeah, a round of applause for everybody that presented. Our technical help got us going. And enjoy the reception this evening. Have Stace tell them to. Oh, yeah. So yeah, one more thing. We the CDF has a cluster here at ESIP, and so we have a meeting every Wednesday, every third Wednesday of the month. So if you're interested in data repositories, come to our cluster, and we give talks about sort of this sort of thing. Thank you.